In this OGE, we learn the second version of the chain rule. So this is the most common version and also the fastest way to find the derivative of a composite function. So we use the chain rule to find the derivative of a composite function. So if we have a composite function like y equal f circle g, so this we can write as f of gx. So we can use the chain rule to find the derivative of things like that. So you can identify two different functions here. So there's a function what we call the outside function. So this is the outside function. And then we have the inside function. So that is always the first step of find the derivatives in chain rule. So we're going to figure out what is the outside function and what is the inside function. And after we do that, so what the theory says that if the outside function f is differentiable, which is differentiable, that means you can find the derivative differentiable at the gx. Gx is a value, so at gx, and g is differentiable at x. Then what it says that it says the derivative of the y function in terms of the original variable x is simply you're going to take the derivative of the outer function and then you can evaluate that at gx, and then you're going to multiply by the derivative of the inside function. So that is the second version of the chain rule. So this is actually the easiest version. So this is very useful, and we can use this in one example here, and you can see more examples in the practice problems. So what we did is we evaluate the outer function at gx. So you can see evaluate at gx. Here what we do, evaluate at x. So evaluate at x. So let's look at a problem and how it works. And before that, I would like to give you all the steps. So there are 5 steps for a problem like that. So let's talk about all those steps now. So the first step is to identify what is the outer function. We normally call this is fu, using a new variable u. And then also we need to figure out what is the inner function. We normally call this is gx in this version. So let's look at what is the second step. The second step is find f prime u. Since you know what is fu, so you can find the derivative of the function, and then you can evaluate at gx. So we normally rewrite this one as f prime gx when you do real problems. That's how we do. So it's like a one-step clause. So look at the third step. So the third step is find g prime x, because we know what gx is. So we can find the g prime x. So that's the third step. So the fourth step. So the fourth step is use the formula. So we can use the formula of version 2. And the fifth step is you're going to simplify. So step 5 is you're going to simplify. So step 5, simplify. So we always do that just to get to the final version of that. I should say if possible. So there may be situations it would be difficult to do. So we can say we can simplify if possible. So those are the 5 steps to do a problem like that. So let's now look at a real problem. So let's look at the problem. Differentiate y equal square root 3x squared minus 8x plus 7. So in this problem you can see that the inside function, this is the inner function, and then this is the outer function. So when you try to find the outer function, you normally consider the inner function just as u. So if you do that, and you can see this is simply square root u, because that's what inside. So that means the outer function is simply y equal square root u. So you can see in terms of two different variables, you have two different functions. Even though we use the exact same variable, there's a kind of abuse of notation here. There are two different functions. One is y equals square root u. The other function is y equals square root 3x squared minus 8x plus 7. These are completely different functions. It's like kind of we abuse the notation here. Okay, so let's write the functions now. So we're going to go step by step now. So the first step. So step 1, we're going to figure out what are the two functions. So in this case, you can see that the outer function is fu equal square root u. That's the outer function, because we consider inner function simply as u. So you can rewrite this one as u to the 1/2. So this is the outer function. Now, and then we can also figure out what is the inner function. Inner function gx. In this case, you can see it is simply 3x squared minus 8x plus 7. You can see this is what is inside. So we call it the inner function. The second step, what we can do, we can take the derivative of the outer function with respect to u. Since this is a square root function, you can see the derivative is simply 1/2 u, 1/2 minus 1. So you can rewrite this one as 1/2. So it's 1 over 2. You can say negative 1/2. So it is square root u, because 1/2 means the square root, but it's a negative, so it's going to go down. And then actually, if you need extra step, you can actually write it like that. So first you can write this in u to the 1/2, positive 1/2, and this is simply 1 over 2 square root u. So that's the derivative of the first function. So the second step, so next step is we can evaluate this function at the gx function, inner function. So that means it is simply 1 over 2, inner function is square root. You can see this is 3x squared minus 8x plus 7. So evaluate the outer function, evaluate the derivative of the outer function at the inner function. So we do. The third step, next we find the derivative of the inner function, which is gx equal, you have 3x squared minus 8x plus 7. This is just a basic power function. So the derivative is simply using the power rule, 6x minus 8. Now what we can do, we can use a formula and plug in those two. So this is step number 4. So the formula is dy over dx using the original variable is f prime evaluated at gx and then multiplied by the derivative of the inner function. So we already know what is f prime gx. We take the derivative of f and substitute gx, so which was 1 over 2 3x squared minus 8x plus 7 square root times g prime x, which was 6x minus 8. So that's the answer. But what we do, if possible, we try to simplify. So this is a simplification step. So what we're going to do, we're going to simplify. You can see that you can cancel 2 and you can divide by 2. So it's 3 divided by 2, so it's going to be 4. So you divide both of them because we cancel the common factor. So that means at the end, so the final answer is simply 3x minus 4 divided by 3x squared minus 8x plus 7. So that is the second version of the chain rule, and you can see this is quite fast, because when you do problems you can actually only need to write these steps, because you can see once you get used to it, you can do this much faster. Okay, so you can, if you need more practice, you can look at the practice problems, and also if you need to know more theories, you can look at the main video about the chain rule. Thank you.